Have you ever looked at the B-52 Stratofortress and just been in awe? This absolute giant of the skies has been a symbol of air power for decades. But as you admire its massive wingspan and imposing presence, one question might pop into your head. Why does it have so many engines? I mean, look at it. 8 engines, 4 on each wing. That's a lot, especially when you compare it to modern heavy aircraft like the C-17 Globemaster or the Airbus A380, which get the job done with just 4. It seems a little excessive, right? Well, the answer isn't just about raw power. It's a fascinating story that takes us back to the very dawn of the jet age. The B-52 is a living piece of history, and its unique 8-engine design is a direct result of the technological landscape of its time. To really understand why the B-52 looks the way it does, we have to rewind the clock to the late 1940s, a period of rapid innovation and intense geopolitical tension. The Cold War was just beginning to heat up, and the United States Air Force needed a new long-range strategic bomber. It had to be capable of flying deep into enemy territory, carrying a heavy nuclear payload, and returning home safely. This was a monumental task. The aircraft they envisioned would be bigger, faster, and fly higher than anything that had come before it. This ambitious project would eventually become the B-52. Now, imagine you're an engineer in 1948. You've been given the challenge of a lifetime. Design an aircraft that can haul over 200 tons into the air and fly it across continents. Your biggest problem? Propulsion. Jet engine technology was still in its infancy. The engines available back then were nothing like the powerful, efficient behemoths we see today. They were relatively weak, thirsty for fuel, and not always the most reliable. The best engine the designers could get their hands on was the Pratt & Whitney J57 turbojet. It was a groundbreaking engine for its era, one of the first successful twin-spool axial flow engines. But even this marvel of engineering could only produce about 10,000 pounds of thrust. 10,000 pounds might sound like a lot when you're trying to lift a 488,000-pound bomber off the runway. It's just not enough, not even close. So the engineers at Boeing did the math. 1 engine wouldn't work, 2 wouldn't work, 4, still not enough power to meet the stringent requirements for takeoff distance, rate of climb, and cruising altitude. The only viable solution was to use a lot of them. They calculated that to safely and reliably get the massive Stratofortress airborne with full payload, they would need a grand total of 8 J57 engines. They mounted them in pairs, housed in 4 pods slung under the long, flexible wings. This arrangement distributed the weight evenly and provided the necessary redundancy. If 1 engine failed, there were still 7 others to keep the plane flying. In fact, early B-52 models were still considered somewhat underpowered, even with all 8 engines roaring at full blast. Getting that fully loaded beast off the ground was a slow, majestic, and very loud process. As the years went by, jet engine technology evolved dramatically. The thirsty and relatively low-power J57 turbojets were eventually replaced. Later models of the B-52, like the H model, which is still in service today, were fitted with Pratt & Whitney TF33 turbofans. These were a significant upgrade. Turbofans are far more fuel-efficient and produce more thrust than the old turbojets. The TF33s offered about 17,000 pounds of thrust each, a huge improvement. But even with this new technology, the Air Force stuck with the 8-engine configuration. The basic airframe design was already set in stone, and changing it would have been a massive undertaking. This brings us to a key point. Why not just re-engine the B-52 with 4 modern engines? It seems like the logical thing to do, right? A modern, high-bypass turbofan, like the ones on a Boeing 777, can produce over 100,000 pounds of thrust. 4 of those would give the B-52 more power than it's ever had, with incredible gains in fuel efficiency and a much lower maintenance workload. The Air Force has seriously considered this option multiple times over the B-52's long life. Proposals have floated by companies like Boeing, Pratt & Whitney, and Rolls-Royce to replace the 8 TF-33s with 4 much larger engines. It sounds great on paper, but the reality is far more complex. Think about the B-52's wings. They are incredibly long and slender, designed to be flexible. They actually droop significantly when the plane is on the ground and flex upwards in flight. The weight and placement of those 4 engine pods are a critical part of the wing's structural design and aerodynamics. Swapping them out for 2 much larger, heavier pods would fundamentally change everything. The airflow over the wing would be completely different. The structural loads would be concentrated in new places, requiring a total redesign of the wing's internal structure, the spars, the ribs, everything. The wing's famous flexibility would be affected. You can't just unbolt the old pods and bolt on new ones. It would be less of a re-engineering program and more like designing a whole new wing for an old fuselage. And the changes wouldn't stop there. Think about the aircraft systems. The B-52's hydraulic, electrical, and fuel systems are all intricately rooted and designed around an 8-engine layout. Changing to 4 engines would mean replumbing and rewiring large sections of the aircraft. The cockpit would also need a massive overhaul. The flight engineer's station is filled with gauges and controls for 8 separate engines. All of that would have to be ripped out and replaced with a new 4-engine management system. Then there's the issue of control. The rudder and other control surfaces on the B-52 are designed to handle an engine failure scenario with the current layout. If one outboard engine fails, the resulting asymmetrical thrust is manageable. Now imagine the same scenario with a 4-engine configuration. The engines would be mounted further out on the wing to balance the load, and a single engine failure would create a much more powerful yawing motion. The existing vertical tail and rudder might not be large enough to counteract it, potentially requiring yet another major structural modification. When the Air Force added up the costs, risks, and the sheer amount of time it would take to test and certify such a heavily modified aircraft, the 4-engine option just didn't make sense. The conclusion was always the same. It would be too expensive, too risky, and would take the B-52 fleet out of service for too long. The benefit just didn't outweigh the massive cost and complexity. So, what's the plan for the future? The B-52 is expected to fly into the 2050s, which would mark an unprecedented century of service for a military aircraft. The current TF-33 engines are old, inefficient by modern standards, and increasingly difficult to maintain. They need to be replaced. The solution, which is now underway, is a perfect compromise. It's called the Commercial Engine Replacement Program, or CERP. Instead of a radical 4-engine redesign, the Air Force has decided to replace the 8 old engines with 8 new ones. After a long competition, Rolls-Royce won the contract with their F-130 engine, a military variant of the BR-725 engine that powers Gulfstream business jets. This like-for-like replacement is a brilliant strategy. The new F-130 engines are almost identical in size and weight to the old TF-33s, but they are a world apart in performance. They are vastly more fuel efficient. We're talking a projected 30% reduction in fuel burn. They're also much more reliable and require significantly less maintenance. They even generate more electricity, which is crucial for powering the new radar, avionics, and electronic warfare systems being installed on the upgraded B-52s, now designated the B-52J. By sticking with 8 engines, the Air Force avoids all the costly and risky airframe modifications. The new engines will be mounted in new 2-engine pods in the same locations as the old ones. The aerodynamics and structural loads on the wing remain largely unchanged. The complex flight control systems don't need a fundamental redesign. It's the most cost-effective, lowest-risk way to keep the Buff, the big, ugly, fat fellow, as it's affectionately known, flying for another 30 years. So, the next time you see a picture or video of the B-52 Stratofortress, you'll know that its iconic 8-engine design isn't a flaw or an outdated quirk. It's a legacy.
It's a clever solution born out of the technological constraints of the 1940s, a design so fundamentally sound that the best way to modernize it, even 3/4 of a century later, is not to change it, but to enhance it. The 8 engines are a testament to the ingenuity of its original designers and the pragmatic wisdom of those who keep it flying. Thanks for watching, everyone. If you found this dive into aviation history interesting, be sure to hit that like button and subscribe for more content just like this. Let me know in the comments what other iconic aircraft you'd like to see us cover. See you in the next one.